Hi, let's talk about the concept of equation. When we talk about equation, it's a statement that the values of two mathematical expressions are equal. In other words, it's a statement of equality between two quantities. The two quantities are the left-hand side of the equation and the right-hand side of the equation. And may I emphasize that the boundary to determine the left-hand side and the right-hand side of the equation is the equality symbol itself. So let us visualize what we mean by an equation. For example, we have this equation 2x plus 1 equals 7. How do we visualize this equation? At the left-hand side, I have here 2x plus 1. So let us going to use this balance beam in order to represent this equation. So let's have 2x, 1, 2, and 1. So 2x plus 1. So I have 2 x's and I have 1 unit. That is the visual representation of 2x plus 1. At the right-hand side of the equality is 7. So we have 7 units. 1, 2, 3, 4, 5, 6, and 7. So notice now that our balance beam is balanced. So we have an equality symbol. We have an equality here. And let's put the equality symbol at the fulcrum. So the fulcrum represents the point of balance. So this would be our point of balance. Now, there are some properties that we can say are self-explanatory that we are going to use in order to deal with equality. For example, it doesn't matter if I put all these 7 units at the left-hand side of this balance and I switch that with the 2x plus 1. Still, I will get a balance beam. That property that says I can switch or I can exchange or I can swap the left-hand side and the right-hand side of the equality, and I am not changing the meaning of the equality, is what we call as the symmetric property of equality. So symmetric. Another property which you can say self-explanatory is I can, for example, remove this 1 unit and put that in our trash bin. And I also remove 1 unit at the right-hand side of the balance beam. What do you notice? When I remove 1 unit here and I remove another unit here, still I get a balance, or I still get an equation. So what's the result? Instead of having 2x plus 1 at the left-hand side, I now have 2x equals 1, 2, 3, 4, 5, 6 equals 6. So what I did was I remove 1 unit from the left and 1 unit from the right hand side of the balance, and I still get a balance. That property that allows me to remove or to subtract equal quantities from both sides of the equality is now what we call as the addition or subtraction property of equality. If I add by a negative number, that is equivalent to subtraction. In some books, they are just using one name for this, the addition property of equality. In some books, you will notice that there is an addition property of equality. There is also a subtraction property of equality. For our purpose, we are going to differentiate these two. We are going to use addition property of equality. If we add, if we subtract, we'll use the term subtraction property of equality. Now, there's one thing here that I would like you to notice. you have here 2x plus 1 equals 7 is the original equation. I remove one unit here and another unit here. I am left with 2x equals 6. Since this 2x plus 6 is the result by subtracting same quantities from both sides of the original equation, we will now say that this 2x plus 6 is an equivalent equation to the original. So 2x plus 6 is equivalent to 2x plus 1 equals 7. And solving an equality is a series of transforming the original equality into series of equivalent equation until such time that we are able to come up with the value of the unknown quantity. We would like to have a form, the variable term equals the constant term. So we want the variable x here and all the constant terms at the right side so that we'll be able to know what's the value of x. Now, you now have here 2x equals 6. What are we going to do with this 2x so that we can just have x? Notice at the left-hand side that you have two groups here of x. So I can divide this into two groups. This is one group, and this is another group. I divide this into two groups. I can also divide the right-hand side into two groups of 3 units. So that's one group and another group. In other words, I can divide both sides of the equality by the same quantities. I divide this by 2, I divide this by 2, and still I get an equivalent equation. So what do I get here? I now have x, because 2 divided by 2 is 1, so 1x or simply x equals 3. So the value therefore of x is 3. When I divide both sides of the equality by the same quantities, we call that as the division property of equality. Instead of dividing by 2, I can just multiply by 1/2 both sides. When I multiply both sides by the same quantities, we call that also as the multiplication property of equality. So these are the properties that we are using in order to transform the original equation into series of equivalent equations. And our goal is, at the final step, we should get the form variable equals the constant term, or the variable term equals the constant term. We now stop here because we now have x equals 3. Now, how do we know if our answer is correct? We can always go back to the original equation. So the original equation is 2x plus 1 equals 7. And we now have x equals 3, so change that x with 3. 2 times 3 plus 1 equals 7. So 6 plus 1 equals 7. 7 equals 7. So we have a balance. Let's have another example. Let us suppose that we have this new problem. 2x plus 3 equals x plus 4. How do we visualize this equation? So you have 2x plus 3, 1, 2, and 3 units, 1, 2, and 3. At the right-hand side, we have 1 and 4 units, 1, 2, 3, and 4. So we have a balanced beam. This is the point of balance. Our equation is 2x plus 3 equals x plus 4. What property of equality are we going to use so that we can transform this into an equivalent equation in the form variable term equals the constant term in the final step? We can do anything as long as we are not violating any mathematical rule, and as long as we are applying valid properties that I've mentioned before, we'll get a valid answer, a correct answer. So let's subtract 3 from both sides. And visually, I do that this way. I subtract 3. 1, 2, and 3. Since I subtract 3 from the left, it's fair that I also do the same on the other side, so minus 3. Or we can just write it as 2x plus 3 equals x plus 4, where 2x plus 3 minus 3 equals x plus 4 minus 3. So we subtracted 3 from both sides. And what do we get? So before I forget, we have to remove 3 units also here. 1 and 2 and 3, and we have a balance. Then simplify the left hand side, we get 2x. So we have 2x here equals, at the right hand, we have x, 4 minus 3 is 1. And then, since there is a variable x at the right hand, and we said we want variable equals constant, what we can do is we remove that x here. So that's equivalent to saying minus x, and do the same thing at the right hand. So I subtracted x from both sides of the equality. So minus x. We have here 2x minus 1x. And the right hand side is 2x plus 1. That's the original. Then I subtract 1x. So this is the term that I subtracted from both sides. All the rest are the original ones. So 2x minus 1x gives me 1x, or simply x. Then 2x minus 1x. Oh, this should be x. Let's clear this one. It should be x. The original is x plus 1. So x minus x gives us 0. So what we now have at the right hand side is simply 1. So we now have 1 here. And so we now have x is equal to 1. So what's now the solution of this equation? X equals 1. Let's verify. 2 times 1 plus 3, 1, the value of x, plus 4. So I have 2 plus 3, I have here 1 plus 4, 5. So 2 plus 3 is 5 equals 5. That's correct. So that's the concept which we call as equality. As long as you apply the properties, and as long as you do not violate any rule in mathematics, you'll be able to get the solution of your equality. But I would like to emphasize that the concept of transforming the original equation into series of equivalent equation. Whenever you apply the property of equality, you are just changing the form of the original equation into its equivalent equation or equivalent form. And since that equation is equivalent to the original, the solution of that equation is still the same as the solution of the original. So you are not changing the meaning of the equation. So that's all for now. We'll deal with some other concepts in our next video. Thank you very much.